Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. But take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called A Couple More Jockeys by Lake, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have index lines, where each turquoise line is an index line. That is, the digit in the nth cell along such a line starting from the diamond indicates the position along the line where the digit n appears. For example, if a diamond cell contains a 3, that means the third digit along that line must have a 1. So that's an example of how index lines work. We have minimums where blue cells with arrows pointing inwards must be smaller than all orthogonally adjacent cells, which are just the cells that the cell shares an edge with. So the 4 cells that share an edge with those minimum cells must all be greater than the digit that's in the minimum cell. So you could have something like, say, 3, 6, 4, 9, and 4, and this would be valid because 3 is less than all the digit cells that it shares an edge with. That's an example of minimum works. And then we have the opposite, which is maximum, where red cells with an arrows pointing outwards must be larger than all orthogonally adjacent cells. Usually it's not greater. Does that include the maximums? Usually it does not include maximum cells either, but it does not specify in this case that that's the case. Interesting. So we can use this as an example. No, it can't be. Yeah, okay. So the reason why you cannot, it has to be all orthogonally adjacent cells other than other maximum cells, is if this cell is greater than this cell, but then this cell cannot be greater than that cell also at the same time. And so that would break the maximum thing. So it's only cells which are also not in red cells, right? That you have to have a maximum. So because if this were greater, if these both acted as maximums, which means this would have to be greater than this cell, this would have to be greater than that cell, obviously that's a contradiction. So that can't work. So this cell then must be greater than just these 2 cells because these are other maximum cells here. And that's not allowed. One of them obviously has to be greater than the other, but we don't have a guarantee either way. But we do have a guarantee that all non-maximum cells that a maximum cell shares an edge with must be greater than the digit in that cell. So you could have something like 5, 1, 4, 2, and 3. And this would be valid because 5 is greater than all the cells it shares an edge with. And that's an example of how maximum works. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So on index lines, the index lines are only going to be up to the length of the index. The digits on the index line, I should say, can only be up to the length of the index line and how many cells it has. Right? Because you can't reference a 6, right? Because that would say that 1 has to be in the 6th spot, but there is no 6th spot in this 4-length line, right? I'm thinking of specifically this 4-length line. Obviously, there's a 6 here in one of these, and the 6 here in one of these. And in addition, on an index line, you have to have the digits 1 through 9 or 1 through the length of the line all appear once each. So this is 1, 2, 3, 4, 5, 6, 7. So these are 7 in length. This must be 1 through 4. This has to be 1 through 6 here, which means we have a 1 through 6 sextuplet in box 7. So this has to be 7, 8, and 9. Now these cells have to be greater than other cells on that share an edge with it that are not maximums. This must be greater than 4 other cells at least, so this is 5 through 9. This must be less than 3 unique digits, because these are unique, because again, on an index line, you have to have unique digits, right? Because you can't, if you had, say, like a 4 here and a 4 here, that would say 4 has to be in the 5th position, but 4 also has to be in the 4th position. And that's not going to work, right? Or say we had this as 1 and 1. That's saying 1 has to be in the 4th position, but 1 also has to be in the 5th position. And so this doesn't know which one to take, right? So is it 4? Is it 5? It doesn't work either way, right? Because that would say that 5 has to be in the 1st position and 4 has to be in the 1st position, and that's not allowed. So you cannot have duplicates here. So these are 3 unique digits here, and they have to be at least 5, 6, or at most 5, 6, or 7. So this is 1 through 4 here. Same with this. This is 1 through 4 here. Okay. These cannot be 7, 8, or 9. That means 7 or 8 or 9 on this index line must be here. So this has to be 1 through 6 here. Obviously, 1 cannot be any of these cells here. So there's no 1 here, no 1 here, no 1 here. This can't be 1, that can't be 1. So 1 on this index line can only be in the 2nd in 6 spots. So this is 2 or 6 here, right? So it could be 1, 2, 3, 4, 5, 6 here. If this were 2, though, 1 would have to be here, and 1 would have to be in the 2nd spot. So this cannot be 2. This has to be 6, which means 1's in the 6th spot. So 1, 2, 3, 4, 5, 6. So we can remove 6 from the rest of the index line. So 1 is here, which eliminates 1 being here. So 1 cannot be in the 3rd or the 6th spot. So this cannot be 3 or 6. 1 is not here, so then this has to be 2, 3, or 4, which means you can never have a 2 share an edge with it, because then it would be higher than that. So whereas 2 on this index line, it has to be either 2 or 3. So this is 2 or 3 here. And we know one of these is 2. So this cannot be 2 here. You cannot have a 2 here, so 2 has to be one of these 2. Since 2 is one either here or here, it's either in the 1st or 4th position. Six cannot be here because of 6 in the column. These must be 1 through 6, but obviously 1 cannot be a maximum. 2 cannot be a maximum either, because if 2 were a maximum, the problem is it would have to be greater than 2 unique digits, here, here, and here. So therefore, where are 1 and 2 in row 7? They have to be here, which means they cannot appear on the index line here. So that means where is 1 and 2 in box 5? It has to be here specifically, because this has to be greater than a 2. So this must be a 1-2 pair here, which eliminates 1 and 2 in the rest of the column, or rest of the row. So this can't be 2. This is 3 or 4, which means none of these can be 3 or 4. We have a 4, 5, 7 triplet in or on this index line, which eliminates 4, 5, 7 in the rest of the index line. So this is 2, 3 as a pair, which eliminates 2 and 3 in the rest of the row. And this 2 or 3 has to be greater than this cell, so it cannot be 3 or 4, so this is 1. Which means this can't be 1 here. So 1 cannot be in 7 position. It has to be in 8 or 9. 2 has to be in 7, 8, or 9. This can't be 1 or 4. No 1 or 4 because of the 1-4 pair in the box. Again, this has to be less than 4, 5, and 7, so this is 3. That eliminates 3 from being here. So 3 can only be in the second, third, or sixth position. So no 4 or 5. Okay. This digit is greater than this, so this cannot be 6. So 9 can be in 1, 2, 3, 4, or 5. Cannot be in the sixth position. 3 cannot be here because 3 would have to be next to 3 has to be on this index. In box 5 has to be on the index line, which means this can't be 3. So 3 is one of these 3. If this were 3, that would force this to be 1 and 2, but the 3 being here would make that a 2, so that's not possible. And this would have to be 3 also, if this is 2. Sorry, if this is 3, this would have to be 1 and 2, which means that couldn't be 2 then. And so this can't be 3 either, so 3 has to be here, which is next to 1 and 2. Which eliminates 1 and 2 in the rest of the column. This can't be 1, it's 4. This can't be 4, it's 1. That means the remaining digits in column 8 are 5 through 9. And this cannot be 9 because it has to be less than this. This cannot be 5 because it must be greater than this. This can't be 6 because 6 has to be greater than that. Remaining digits in row 2 are 5 through 9. Remaining digits in box 3 are 5 through 9. This can't be 6 because of 6 in the box. Okay. Three can never be in 7, 8, or 9. So this cannot be 7, 8, or 9. It could be 3, 4, 5, or 6 there. This digit sees all 4, 5, 7, and these have to be different digits. So that means this can't be 4, 5, or 7. Can't be 1 or 3. It could be 2, 6, 8, or 9 here. These digits are less than 6 guaranteed. So we have 1 through 5, 1 through 5, no 3 here though. 1 through 5, 1 through 5, but no 3 there. So this digit is guaranteed to be greater than these two digits. It also has to be greater than 1, 2, 3, 4 other digits, right? 6 through 9 is definitely greater than 1 through 5, guaranteed. And it has to be greater than these 4, so it's greater than 6 digits, so this cannot be 6, it's 7, 8, or 9, which eliminates 7, 8, and 9 in the rest of row 5, because we have a 7, 8, 9 triplet. So this can't be 7. That leaves this as 2 through 6, 2 through 6, and 2 through 6. No 3 here because of 3 in the row or box. 1 eliminates 1 from being here. And it can't be 1 here. This cannot be 2 and 3. Because if this were 2, so if this were 4, this would have to be 2 and 3 to be next to it. Because this is great, they would have to be greater than these two cells. But that would eliminate all possibilities from this cell here. So this is not 4. In fact, we have a 2, 3, 4, 5, 6 quintuplet in column 9, which eliminates 2, 3, 6 in the rest of the column. So this can't be 5 or 6. This is 7, 8, 9, 7, 8, 9, 7, 8, 9. We have a 1, 2, 3, 4, 5, 6 quintuplet in box 9, which eliminates 1 through 6 in the rest of the box. So this can't be 5 or 6. It's 7, 8, 9. This is 7, 8, or 9. So we have a 7, 8, 9 triplet here, which means this is a 7, 8, 9 triplet here. Interesting. Huh. Remaining digits in row. So 7 has to be one of these two, which means this can't be 7 because it sees both cells. Remaining digits in row 3 are 4, 5, 7, 8, 9. So again, this can't be 7 because it sees both 7s here. 7 has to be in the 4th or 5th spot. That's fine. This could be 4 if 1 is one of these two. Okay, so this can't be 1, 2, or 3. So we have 4 through 9 here, 4 through 9 there. Okay. One, two, three, four, 5. That's limited. So 4 is here, which means that 2 has to be in the 4th position. So that's 2. This is 3. So there's no more 2 here, no 2 here, no 3 here. So this can't be 2 either. 3 has to be one of these two. Huh. Two can be in any of the 6. We already limited 3. Hmm. Hmm. Okay, so this 4, 5, or 6 sees that cell there. So this can never be that 4, 5, or 6 because, again, this 4, 5, or 6, this digit here has to match this cell here because it cannot be on the index line. And if this is matching that, if this is 4, 5, or 6, it would be in the same, it would have to be the same digit as that, which is impossible. So this must be 2. So therefore, this cannot be 2 left here. So that's saying 7 has to be in the 2nd spot. So this is 7, which eliminates 7 here. This can't be 7 here. It's 8 or 9. That means we have 1, 8, or 9 here because it cannot be in any of these spots. That means the other 8 or 9 has to be here. So this is 8 or 9. Okay, let's mark them with colors. We're going to make this green, this orange. That means green has to be here, which makes that orange. Orange has to be this. So green is one of these 3. Green is one of these 3. Okay, so 9 could be in only 1, 4, or 5. 2 eliminates 2 here, so this is 3, which makes this 2. That means this can't be 2, it's 1, which makes that 2. So 1 cannot be here, 1 has to be here. So 9 has to be in the 1st spot. So this is 9, which makes this 8, so this can't be 8 here. So that means this is 8. Obviously, this can't be 8 anymore. We do not have a 9 available here. So 8 can be in 4, 5, or 6. This matches this cell. So this is yellow. 6 eliminates 6 here, so this can't be 6. So we have a guaranteed 6 in one of these cells. So 8 has to be in 4 or 5, so this can't be 8 there. This can't be 3 here, so this has to be 4, 5, or 6. 9 eliminates 9 here, this can't be 7. We have a guaranteed 3 here, which means 3 cannot be here, so 3 is either in 2 or 3 here. 8 eliminates 8 here. This has to be 3, 4, 5, or 6. We have a guaranteed 6 here. So that means 6 cannot be either of these two, which means 6 cannot be in the 6th position or the 5th position. So it's either in 2 or 4. Okay. Where is 6 in row 7 or row 4? Cannot be here because this has to be the same digit as that, and 6 sees that there. 6 sees this cell because it's on the same index line, and these are filled out. So 6 has to be one of these two, which eliminates 6 in the rest of the box. So now we have a 1, 2, 3, 4, 5 quintuplet in box 6, which eliminates 1 through 5 in the rest of the box. No 4, 5, no 5. This becomes a 6, 7, 9 triplet, which means this can't be 6, 7, or 9. It's 4, 5 as a pair. Therefore, where is the 7 on this index line? It must be here, which means that 4 has to be in the 7th spot. So this is 4, that's 5, which makes this 4. Therefore, this is 4, which is saying 8 has to be in the 4th position. So this is 8. This cannot be 4 anymore. No 4 here. This can't be 4. It's 3 or 5. That's saying 5 can only be in the 3rd or the 5th position. Cannot be in the 6th position, so this is 6. This can't be 4, 3, 4, or 6, so it's 5. No 4 or 5 here, so this is 3, 6 pairs. 6 eliminates 6 here, so this is 3, that's 6. 3 eliminates 3 here, so it's 5, which forces this to be 3. So no 3 here. This is 3 here. This 4 eliminates 4 here, so it's 5, and this can't be 4 or 5. It's 2, which makes this 1, which makes that 4. This can't be 4 or 5. It's 6. So this can't be 6 here. It's 2 or 9. 4 cannot be less than or greater than 4. So, or equal to 4. So this can't be 4. No 5 here because the 5's in the column. So this is 6. This is 4. This can't be 6. It's 5. So there's no 5 here. It's 1, 2 as a pair, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. It's 3, which is saying 3 is in the 3rd position. No 1, 2, 3, 4. So this becomes 5, 6 as a pair, which is in the 2nd and the 4th positions. So this has to be 2, 4 as a pair here, which makes this 1. 4 eliminates 4 here, so that's 2 and 4. That's saying 6 is in the 4th position. So this is 6, that's 5. No 7 here. We have now a 4, 5, 8, a 4, 5, 6, 8, 9 quintuplet in box 1, which limits 4, 5, 6, 8, and 9 in the rest of the box. So this is 1, 2, and 3. 1 has to be here because of 2 and 3 in the column. 2 eliminates 2 here, so it's 9. This can't be 1 or 3, so that's 2, which makes that 3. 5 eliminates 5 here, so it's 9. This can't be 5 or 9, it's 4. 9 eliminates 9 here, so it's 7, which makes the last digit 2. This can't be 4. No 4 here, no 4, no 7 here. No 7 or 9 here, so this is 8, which means this has to be 9. This can't be 6, 8, or 9, it's 5. This can't be 5 or 9, it's 8. This can't be 5, 8, or 9, it's 6. Which leaves this as a 7. 8 eliminates 8 here. This can't be 5 or 9. It can't be 5, 6, or 9. So we have 7 or 8. 8 eliminates 8 here. So this is 7 and 8. That means 8 cannot be either of these digits. So this is 8 here. 1 eliminates 1 here. So it's 2 and 1. This can't be 8 anymore. 7 and 8 eliminates 7 and 8 here. So this is 9. This is 8. That's 7. 9 eliminates 9 here. So it's 5 and 9. Which eliminates 9 here, so it's 7 and 9 there. 9 eliminates 9 here, so it's 7 and 9. 7 eliminates 7 here, so it's 6 and 7. And we're just doing normal Sudoku here. This is then 4. This is 9. This has to be... wait, no, this is 4. I don't know how I got 4s there. This is 8, 9, and that's 4. That leaves this as 6 and this as 5. And that's a solution. Yeah, fairly straightforward through this. It uses index lines actually very well. This was in particular a very cool little trick here, right? So that was actually really cool. But just overall used the index lines and the maximums very well. So, nice little puzzle. Anyways, I actually don't know where the jockeys are. Are they supposed to be... I don't even know. I mean, I guess these could be horses? I don't even know. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.